My name is Gopal Rao, and I am the Chief Editor for Technical Content at the Materials Research Society, MRS. It is a great honor and pleasure to be talking with Dr. David Morse of Corning, Inc. today. Dr. David Morse is Corning's Executive Vice President and Chief Technology Officer. He's responsible for managing Corning's innovation portfolio and creating new growth drivers for the company. He has a doctorate from the Massachusetts Institute of Technology, MIT. Among his many honors, he has been elected to the National Academy of Engineering and is a fellow of the American Association for the Advancement of Science, AAAS. Welcome, David, and I'm very happy to be talking with you today. Corning, of course, is one of the great materials companies, and material science is built into your DNA in one sense. So I appreciate your agreeing to chat with us today. So let me start with something that we're all preoccupied with these days. The COVID-19 pandemic is the major current issue worldwide, obviously, impacting the global population. How has this affected R&D efforts at Corning?
You know that we're in the state of New York for our biggest lab. Most of our scientists and engineers are in New York, and New York was shut down early on. And so we were asked to all go home. And then we had to work back from there. There are some things that we do that qualify as essential industries. And we were able to bring back all the people that were in essential industries. But that still only occupied the lab at about 30%. So it was necessary to begin, as everyone did around the world, working from online and doing the best we could to keep the lab going. And what we found, and I think what my peers and other industrial labs found, is that to our surprise, we really didn't fall behind. Work continued. People were moved towards reviewing their work and writing reports a little more. We launched online education for people that might not have been as likely to do it when they were in the lab full time. And then slowly we were able to bring people back until by July, we had about 70% peak population at the lab. So, and it's been a continuing story. As we've had cases go up in our area, we've had to de-densify the lab, as we say, keep the population to the lowest possible while still keeping everyone safe and doing the work. And that's the state that we're in right now. But the biggest message is that research, development, and engineering have all continued amazingly unabated in the face of this massive challenge.
Oh, that's very interesting to hear. Now, everyone is, of course, interested in a vaccine for COVID-19, but there are many other mitigating efforts that are ongoing. Are there COVID-related areas, biomedical or others, where Corning's technology would be critical?
Yeah, actually, there are. We have a division which is Corning Life Sciences, which provides tools both for research labs, academic, industrial, and governmental, as well as some scale up for cell growth and new technologies for new types of medications based on biologics. And the demand for the products that we make for those industries is higher than we can supply. Very high demand. And we're working hard on industrializing new methods of making some of these things so that we can supply the needs of the country and around the world. We also have our new division, which is Corning Pharmaceutical Technologies. Corning had been in pharmaceutical vials from the very beginning, so we were the company that people came to make vials for the first polio vaccines back in the 1950s. which of course, that those developments by SOC changed the world. But they needed packaging, and we provided it. Over the years, we got out of that business. But as new biologics have been developed with higher and lower pHs than drugs had formerly, it became evident that a new glass solution was necessary. And we did develop a new glass, an aluminosilicate non-boron containing glass for making vials, and we are in the process of scaling that up as rapidly as we can. And we received a large United States government grant, over $200 million, to build a plant in North Carolina to scale it up as fast as possible, all devoted to the pandemic. And that business, while it's still scaling up, remains sold out as well, making as many as we possibly can to support both the drugs to treat COVID-19 symptoms, as well as for the vaccines. It will be a world effort between Corning and other companies to provide all the vials that are necessary. So yes, we're right in there.
Yeah, good to hear that Corning has an important role to play in this. So.
Yes, feels good.
Now, Gorilla Glass, obviously, undoubtedly is one of Corning's best-known products. I have it in my mobile phone, which is right next to me here.
Sure.
Can you describe the latest version of Gorilla Glass and its properties and future directions for this?
Well, Gorilla Glass has been a lot of fun, and we've continued to come up with newer ways of making the compositions and new ways to ion exchange the glass to make it stronger and stronger. But this latest one that was just announced by Apple is the furthest we've ever gone, and it's of particular interest, I think, to MRS members, because it's no longer a glass, it's a glass ceramic. Oh. And you may remember that Corning invented glass ceramics, Don Stuckey, back in the 1950s, and that led to the business that we were so well known for many years, Corningware, the glass ceramic cookware. And we also, during that time when we were in cookware, or not anymore, when we were in cookware, we invented a transparent but colored glass ceramic called Visions. It was based on beta quartz in glass. It was 99% crystallized, but was still transparent. And that was particularly, one of the key inventors on that was Dr. George Beale, whom you know well at the Society. And we always wished that we could make that actually both transparent, totally transparent and colorless, but we never succeeded in that back in the days that we were in cookware. And then fast forward to modern times, more than 50 years later. And we managed to invent a clear glass ceramic that is absolutely transparent, just the way Gorilla Glass is on your current device, and which is strengthened by having crystals in it, and which is also ion exchanged. And the two things together end up making this an extremely strong material. The press has used the term 4 times as strong for fracture toughness as our strongest previous glass, and that's accurate. In fact, even a little conservative, I'd say. The performance is just amazing. And I think that it's going to make life a lot easier for people who are really rough on their phones, and for those people that don't buy cases and like to have them just as they came. They'll enjoy something that is safer. So it's a great product. We've continued on the non-glass ceramic side as well, and we did announce a 7th version of Gorilla Glass, which is called Victus, And that one too is quite a move forward from the previous Gorilla Glasses that we've made, and that is showing up at some of the major product providers right now.
Excellent. We'll certainly have many fewer shattered screens, I'm sure, in the future.
The initial, there's always a lot of people on the internet who take pride in testing these phones in the ultimate ways that they can think of, and so far, so good.
Very good. Corning is, of course, also known for applications in optical fibers and specialty glass. But it's interesting to note that there are many other lesser known applications that you are working on. Can you maybe point to one or two unusual application areas being developed at Corning?
Sure. I think we're thought of more often for glass than we are for ceramics, but ceramics are a big part of what we do. And I know that most people are familiar with substrates for catalytic converters. They've been around since the early 1970s. But more recently, we had diesel soot filters, and then just recently gas particulate filters. And gas particulate filters are used because when direct injection gas engines are used, the direct injection creates many more particles, nanoparticles, than in a regular older fashioned gas engine. And so gas particulate filters are mandated in both Europe and in China, two of the biggest markets. So we developed a product there, and it's going on the new cars. And we took that product and we used it to filter indoor and outside air of particulates. And it works very well for that. And it can be used to filter air for a long period of time and then washed off and reused. So it appears to have a long lifetime. We're projecting 20 years. And that product has been in a competition in Europe, looking for ways to filter air, and it won that competition, which was a nice over $1 million euro prize. And then we competed in Korea, in Seoul, in the subway system, and we won a competition there as well. And so we're starting our first installations in the subway in Seoul, and we'll see if that becomes a commercial product. But it looks very interesting right now, and it has special properties such as the ability to filter micro and nano metallic particles out of the air, which are present in subway systems because of the grinding of the wheels against the rails. And if you try to capture metal particles using paper filters, they cut right through, and cloth as well. So it has unique capabilities and has very long lifetime. And I'm really hoping that this will become a significant technology for filtering air, both in closed systems, indoors, in semi-open systems like subway systems, and then maybe even in some more open systems like parking garages or urban areas that are closed in and where the air does not filter out much. So we'll see. Another one is that is new to us in ceramics is our ceramic tape technology, which is continuous manufacturing of very thin ceramic tape. The first material we did was a simple one, alumina, but we've ended up with alumina, which is different than you're able to access from other methods. It's more transparent, not totally transparent, but more transparent. Has outstanding heat conductivity, which alumina is already very good at, but it's better than regular cast alumina. And it can be made in a continuous strip form. So we think that making ceramics in this way is different, and that it allows us to move into potential applications in electrodes or batteries, which are so important to our future as we move away from internal combustion engines. And certainly Corning would love to be a part of the solution for battery electric vehicles and batteries for other applications as well.
Now, in your presentation, you touch upon artificial intelligence as playing an increasingly important role at Corning in R&D.
Yes.
Can you expand on Corning's use of artificial intelligence, machine learning, especially for materials design aspects?
Well, we've embraced that as wholeheartedly as we can. The number of people doing modeling and simulation at Corning has increased dramatically over the years, and there are over 200 now who are experts in that field. And we have set the goal of design of new materials using the earliest forms that are appropriate of machine learning and AI. And with some success, the Gorilla Glass that I mentioned, Gorilla Glass 7 or Victus, was actually designed on a computer. The composition was designed there, and it was moved rather rapidly to production and worked very well. So on the invention of materials side, I think really we can't even begin to estimate what's going to happen in the world as these tools become available. But it takes a huge amount of skill to design them to fit into the systems that we work with, to make them multidimensional in terms of many different components. And I know that we're only at the very beginning of knowing what we can do long term.
Fascinating. That parallels what we are seeing in so many other areas of material science.
Yes.
AI is being used today. So I'd like to end by talking a little bit about the role of industrial R&D labs. So in the past, major industrial labs like Bell Labs or Westinghouse that used to be located here in Pittsburgh, where I live, have played major roles in both applied and fundamental research. From Corning's perspective, what do you see as the role of industrial R&D labs in the research enterprise?
Well, you'll not find a stronger proponent of the value of industrial research, and I emphasize the research, despite the fact we do research development and engineering. It takes a huge amount of engineering to scale up, but the research part is critical to the long life of companies like Corning, and to all the new companies that are coming along around the United States and around the world. I just can't overemphasize how important it is to us, and how the chairman of Corning, Wendell Weeks, the board of Corning, all strongly support long-term investment in R&D, and the fact that Corning wants to be a company that's still here. What we say is we've been here for over 160 years. We'd like to be here for another 160 years. And you know, that sounds silly on the face of it, but it's not impossible, because research will always yield inventions, always. And whenever in history we've come to a point where some scientists have said, well, that field is exhausted, we find that huge inventions are made. And your example of Bell Labs is the perfect one, because in the early 50s, it was often said, well, optics is a closed field. I mean, everything that's going to happen in optics has happened. And yet, within 10 years, Bell Labs had significantly participated in the invention of the maser and leading to the laser, and of course the transistor. And those two things completely changed and continue to completely change everything that happens in the world. With Corning being involved, sure, we were involved in optical fiber and the competition to make the best one, as Bell Labs were, and that was part of the outcome. As long as we invest in R&D, we'll continue to make inventions and we'll improve life, and we'll I hope, deal with the challenges of global warming and high population, and all the things that we face have to be dealt with by doing good science. And it'll happen in government labs, it'll happen in academic labs. The difference with industrial labs is we also have the engineers. And so once it happens, regardless of where it starts, we can turn it into reality. And that's one of the hard parts. And I think we can do that. So I'm the strongest of supporters. I've spent my whole career on this, 44 years at Corning, and I sure hope it goes on for the rest of my life.
Well, thank you, David, for talking with me today, and we'll continue to keep an eye on all the new and innovative technologies and products, including future versions of Gorilla Glass coming out of Corning R&D and material science. So thank you again.
Yes, thank you. Thank you, Gopal, for the opportunity. I deeply appreciate it, and happy to spread the word on the value of research.